Hi, and welcome back. In Lecture 20, you learned about the DC motor, a versatile yet low-price solution for providing motion to your projects. A weakness or characteristic of the plain vanilla DC motor is that it spins like crazy, and while it does, we don't know where the shaft is or how far it has traveled because there is no feedback provided. Once you apply power, it wants to go as fast as it can for as long as it can. This is great for applications where continuous movement is needed, like for propelling a vehicle, but not when we need precision and control. Imagine building a robot that can perform surgery on humans. Some of you may hopefully work on something like this in the not-so-distant future. In such application, precision and confirmation is paramount. You don't just want to tell the motor to rotate its shaft by 90 degrees. You also want confirmation that it did. In Lecture 20, there was a mention of the servo motor. This is a spruced up DC motor that includes circuitry for fine movement control and feedback. In this lecture, we will learn about how to use this kind of motor. We will use both the built-in servo motor library that comes standard with the Arduino IDE and a third-party library that adds a bunch of very useful features. In the first demo, Quick Start Guide, we are going to use a servo motors library that is built into the Arduino IDE. That way we're going to start playing with a servo motor very quickly. This is what we're going to assemble. There are a couple of things to notice here. First, there is no motor breakout like we used in the DC motor lecture. Back then, I said that because the Arduino cannot provide much current, it's best to always use an external power source to power our motors, and that is what the breakout board was meant to do. I did not like back then, but sometimes we need to make an exception. In this circuit, my servo motor is small enough to not stress the Arduino too much. So I decided to plug it in straight into the Arduino in order to keep things simple. But that's not where this decision ends. Notice the big round tube at the lower part of the breadboard. That is a capacitor. Even though my servo motor is small, occasionally it may draw more power than what the Arduino can provide, but only momentarily, like when it starts a new move. To counteract that, I have plugged in a capacitor between the ground and 5-volt columns. A capacitor is a reservoir of electricity, a bit like a battery that can charge and discharge very quickly. Plugged into the circuit like this, when the servo motor starts and draws more power than what the Arduino can provide, the capacitor will start discharging and providing the motor the additional power it needs. Just plug in a capacitor that is 300 millifarads or more and you'll be okay. Be careful though, because most capacitors are polarized. They are going to have a minus and perhaps a plus sign on the sides of the tube. Make sure that you plug the pin marked with the minus sign against ground and the other side against the positive voltage. So let's go ahead and have a look at the assembly and the demonstration. What we'll do now is to assemble a couple of circuits that will allow us to control this servo motor. I'm going to do that using both the built-in servo library plus a third-party servo library that will give us a few nice additional features. This is what a servo motor looks like. It's a normal DC motor powering the whole thing. But there's also a bunch of gears so that the motion is transmitted to the shaft, and then we can attach various things that we want to move around at the end of the shaft. But there's also a bit of circuitry here, as you can see. It's an integrated circuit, plus there's a little tracking device here that provides feedback about the actual position of the shaft, so that allows us to be very precise with our movements and also to be able to confirm the movements. Now, unlike the DC motors lecture, I'm not going to use a motor breakout board, a motor controller. I'm going to plug this motor directly into the Arduino because it is small enough. However, just to be sure that I don't cause any problems with the Arduino's inability to provide large currents, especially when the motor is starting and is moving, I'm going to use a capacitor. So you can use this capacitor as, think of it as a little battery. It's capable of storing electricity in it and then to discharge this electricity when it's needed. So what happens is that this capacitor will be charged pretty much as soon as it's plugged into power. It only takes a few nanoseconds. And then when the motor is moving, especially at the moment that it starts and it draws a little bit more current than when it's operating normally, this capacitor is going to discharge its electricity and help out the Arduino with providing the power that the motor needs. Okay, so I'm going to start by first plugging in the servo motor. I'm going to use jumper wires to help out with plugging these leads into the breadboard. So the white lead is going to go to digital pin 9. It's going to provide the control signals. Then I'm going to use the red wire to power black wire to ground. And then from here I'm going to provide 5 volts positive and ground to 5-volt column and the ground column. I'm just going to plug the capacitor in. Just be careful, this is a polarized device, so you need to make sure that you plug the negative to ground and the other lead, the longer lead usually, to positive voltage. So negative is going to go to the blue strip, the blue column. Okay, that should do it. Let's provide power. And I'm going to go to the Arduino IDE and use one of the examples that come with the IDE. So you go to File, Examples, look for Servo, and use and bring up the sweep example. So let's upload it and then have a look at how this sketch works. There you go. So this sketch moves the shaft 180 degrees back and forth, increasing by 1 degree. Very simple. Let's see how the sketch works. First, we'll begin by including the servo library, just like we've done many times in the past. Then we create the servo object and get a handle to it using the myServo variable. And we declare that the current position is going to be at 0 degrees using an integer variable pos. In the setup function, we attach the servo control pin to pin number 9 on the Arduino. So by saying attach 9 tells us that the white wire, which controls the movement of the shaft, will be plugged into digital pin 9. In the loop function, we have 2 loops. The first loop We start with the position of the shaft at 0 degrees with incrementals of 1 degree, gradually moving the shaft to position 180. That's 180 degrees. So we're going around this loop 180 times, and each time we use the myServo.write function to write the new position to the servo. Okay, and then it takes a little bit of time for the servo to move to the new position. So we give 15 milliseconds to the servo to complete before we write the next position to it. Once we reach the end of the movement, so 180 degrees, then we'll move on to the next for loop, which counts down in this case. It decreases the position of the servo motor from 180 gradually down to 1 at 1 degree every time it does an iteration. That was good, but we've got more to look at. Let's now attach a rotary potentiometer and adjust our sketch to enable us to control the motor by turning the knob. The potentiometer is attached to power, and the middle pin goes to analog pin 0 on the Arduino, like we've seen before. Okay, so that's pretty simple. It's not much fun though, because the Arduino is doing the controlling. We'd like to be able to have manual control of the servo. So to do that, we're going to use a potentiometer. With the potentiometer, we'll be able to turn the knob. And as we're turning the knob, to make the shaft of the servo to move accordingly. So let's wire it. With power first. And I'm going to take a reading from the middle pin of the potentiometer using analog pin 0. Nothing else changes. So let's bring up another example from the IDE. So examples, servo, knob. Upload it, make sure it works, and then we'll examine the script. Not connected. I should first connect it to my computer. Alright, try to upload again. There we go. So, as I'm turning the knob, the servo motor moves accordingly. So it's 180 degrees on one side and 180 degrees to the other side. Looks like it's a little bit less, but that's the range of this particular potentiometer. That's how far I can turn. So how it works, exactly the same story as before. We include the servo library. We set the pin for the potentiometer, so that's analog pin 0, and we declare an integer variable that we're going to use later. In the setup function, we attach the servo to digital pin 9, and then in the loop function, we constantly take readings from the potentiometer. Then we use the map function to map the readings from the potentiometer, which range from 0 to 1023, to values that the servo motor can receive through the write function, which range from 0 to 179. And then just like before, we write that adjusted value to the servo mechanism, and then we give it 15 milliseconds to finish moving. That's all there is.